Hi folks, welcome back to Physics with Captain Rod. The purpose of this video here is just to introduce the first law of thermodynamics. So I'm going to start by writing out the work-energy theorem as we've seen it lots of times if you've watched lots of my videos here. And it says basically the sum of the total mechanical energy of a system plus any work done on the system equals the new sum of the total mechanical energy of the system. And the first law, or the work-energy theorem, can be modified and just made more generic by adding more energy terms. So, for example, if we take a look at this system over here, we have this water here, or maybe this piston cylinder assembly that I've drawn up here, where these different colored dots are representing a bunch of different types of molecules in there, or some sort of gas within the system. And again, I use the term gas there in the context of the state of matter, not like gasoline. And there are different ways that we can change the energy state of these systems. We can do work on them. For example, we could compress this cylinder here. We could apply a force maybe in this direction and compress this system. But the other way we can change the energy state of the system is by heat. You know, maybe we combust some fuel in here or something like that. So heat is another way that energy can be transferred. So I'm going to take this first law of thermodynamics. So what I'm going to do, I'm going to take this work-energy theorem, and I'm going to just make myself some room here. And the energy state of a system can be changed by work, but it can also be changed by adding heat. So I'm just going to put a plus Q here. Now, if I add heat to either of these systems, what's going to happen is the temperature will likely go up. And the energy that you're changing when you do that is kinetic energy, but remember, it's molecular kinetic energy. And we describe that, the molecular kinetic energy of these systems, with what we call internal energy. Remember that internal energy, if you see my previous video on this stuff, internal energy is basically the sum of the kinetic energies over all molecules in these systems. So I'm going to go ahead and use IE for internal energy terms, and I'm just going to generalize my work-energy theorem a little bit more even. I'm just going to add an IE1 and an IE2. So all I've done is taken this work-energy theorem and included potential terms for heat transfer and internal energy terms. Now, in thermodynamic problems, like the ones I'm talking about on the right, generally the potential energy of the system, maybe with respect to some datum, or maybe the kinetic energy of the system, the bulk kinetic energy of the system, meaning that maybe the speed that this entire system is moving, is generally not important for most thermodynamic problems. Usually when we talk about energy transfer in thermodynamics, we're talking about heat transfer and internal energy terms. So basically in thermodynamic problems, we're usually not going to need these terms here, 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 and here. So what I'm going to do is just rewrite it without these terms. And what we're going to have now is internal energy 1 plus work plus heat equals internal energy 2. If we go ahead and just take this term and move it over to the right, what we're going to have is work plus heat equals the change in internal energy of a system, because internal energy 2 minus internal energy 1 gives the change. In this law right here is the first law of thermodynamics, that the change in internal energy of any system is equal to the heat done heat transfer to the system plus work done on the system. You will see this written in books various ways. I like to write it like this: change in internal energy equals heat plus work. There's a sign convention that needs to be understood here. With this plus sign here, I am defining work as work done on the system. That's actually important, because some books, when you read the first law of thermodynamics, you'll see something like change in internal energy equals heat minus work. If you see the minus sign, that's because whoever wrote the law is defining the work as work done by the system. And that's just different viewpoint. I always like to talk about work done on the system, because then it's very consistent with the theorem of work and energy as we've always applied it. If you see it written like this, it just means that whoever wrote the first law of thermodynamics, in that context, their work term is work done by the system, not on the system. And the difference has to do with a plus or minus sign when you calculate the work. So work is pressure times change in volume. When you take this convention, work done, I have a Y there, but work done by the system, your work term is considered positive when the system expands. And you'll notice that when your change in V here is positive, you'll get a positive value for this. Now, an expanding gas tends to cool. And notice that your change in internal energy equals heat minus a positive value. That work term would have the effect of dropping your internal energy. If you define work done on the system, when you calculate the work done on a gas, it's minus P delta V. And now when the gas expands, the work term is considered negative. And when you input a negative number here, you get a drop in internal energy. Now you'll notice in both cases, the work done by the expanding gas has the effect of dropping the internal energy. So it doesn't really matter what version of the first law of thermodynamics you use. You just have to be consistent with how you calculate your work term. Just remember this. When a gas is expanding, the work term for that expansion should drop the internal energy. That should give you a negative change in internal energy. And when the gas is being compressed, the work term should have a result of increasing your internal energy. So again, this video is just meant to be an introduction into the first law of thermodynamics. Well, here it is. Again, the plus or minus sign on the work term, that's kind of optional. It depends on viewpoint. In most videos I make, I will stick with the sign convention of work done on the system, which means plus sign right here. So anyway, hope this video successfully introduces you to the first law of thermodynamics. Have a great day.